Hello, everybody. Welcome back to the Math for Healthcare video lecture series, and here we'll see the third of our Introduction to Probability lectures. So let's go back. We got two dice are rolled. Find the probability that the sum of the numbers is 9. So if you recall, we used the square and we said there's a first die and a second die, or a red die and a blue die. So we saw that the size of our sample space here, is 36. Okay? Now, if you don't remember how we got that, please refer to the two dice sample space sheet that's in Eagle Online or the last video to see the one that we used there. All right. Now, so that was 36. What's the sum of the numbers is 9. So let's say E is the event that the sum is 9. All right. Well, the probability of E is, well, how many ways can we get a 9? If you look at that chart, it comes out that there's 4 ways, right? 5, 4, 4, 5, 3, 6, and 6, 3. This is going to be 4 out of 36. All right. Hopefully remember that kind of thing. Now, how about, though, if we have the numbers 1, 2, 3, 4, 5, 6 written on slips of paper, and the 2 slips are drawn without replacement? Find the probability that the sum of the numbers is 9. Okay, so here, is the sample space the same size? No. Let's take a look at our sample space. Oh, geez. Right here. I guess I got to do some erasing. Now, this was for a die. What can happen here if we're pulling out slips of paper and we're not replacing them? That means that you can't get doubles. So we have none of these things here, right? And so that gives us, what's our new sample space size is now 36 minus that 6, which is 30. Okay? And now we want the event E that the sum of the two papers is 9. And the probability of E, we just have to find the size of E. Okay, 9, so what's that going to be here? That's going to be this 6, 3, 5, 4, 4, 5, and 3, 6. Okay, and that turns out to be 4/30. All right. Those two questions fundamentally are different, and we will explore this idea more in the next videos on conditional probability and independence, where we see that when the dice, that's fundamentally different than when you can't get the doubles. We'll explore that more later. Okay, so how about something like this? We're given probability of E equals 0.26, probability of F equals 0.41, the probability of E intersect F equals 0.16. So notice we could use our union formula to get that the probability of E union F is 0.26 plus 0.41 minus 0.16, and that gives me be careful here, 0.51. Okay? 0.51. Now we could use a Venn diagram just like we did before with finding the size of sets, except for now we're going to put the probability in each region. Okay? So let's say I have E and I have F. Okay? here, that probability of their union, well, we could fill it out, a complete Venn diagram, and just have those numbers ready for us. We know that, okay, the intersection is 0.16, right? So outside of that intersection, but still in E, we end up with, let's see, the probability is 0.1, right? And F is going to be F, but not in the intersection, is 0.25. And notice what? Our last region, we already know what that is, right? That's going to be everything outside the union, which is 0.49. All right? Now we have it all sussed out. So let's see what we got here. How about the probability E complement intersect F, right? We have to find where that is. Intersect F and its E complement. That is going to be, I want you to do this on your own. Hit pause. The green section. So that's going to be 0.25. 0.25. Similarly, the probability of E intersect F complement, that's going to be that 0.1. Over here, that's that yellow area. And then the probability of E complement union F complement. I think the easiest here is to use De Morgan's. And we know that probability of E complement union F complement equals the probability of E intersect F, the whole thing complement. And so that's equal to 1 minus the probability of their intersection, which is equal to 1 minus 1/6, which comes out to be 0.84. Just so we know we got this to be 0.84. And that's how we could use a Venn diagram and probabilities together. Now, sometimes you'll hear people say odds rather than probability. They're tied. They're tied together. It's just a different way of writing it down. And this is something you'll see, if you go out and bet on sports or something, you'll see odds quite a bit. All right. So here's our definition. It's just the proportion, or the ratio, of the probability of E to the probability of E complement. And if the odds are m to n, then we get these formulas for the probabilities of E and E complement. So suppose you roll a fair die. What are the odds you roll a number greater than 2? Okay. Well, let's say E is the event. Roll number greater than 2. So we need the probability of E is what? Greater than 2. We got 3, 4, 5, and 6. So that's going to be 4 out of 6. And automatically that tells us the complement is going to be 2 out of 6. And so the odds are 4 to 2 in favor of E. Okay, or grading number greater than 2. What are the odds of Montana Rodeo Queen winning the Kentucky? Okay, so now the other way. The odds of the Montana Rodeo Queen winning the Kentucky Derby are 5 to 7. What's the probability of Montana Rodeo Queen winning the race? So we're going to use this. Okay, here, and that tells me my numerator. Let's say that's my event E, Montana Rodeo Queen winning the Kentucky Derby. I have 5 divided by the 5 plus 7, or 12. And that's how to go back and forth between odds and probabilities. Hopefully some practice questions will make that clear if it's not today. All right, well, that's the end of our introduction to probability series here, and we'll start on conditional probabilities and independent events next video. Have a great day.